Hello friends, welcome back to the program. Today we are going to look at some text performance stuff because lately I've been running the system with vector fonts as a system font, as you can see here, and I'm noticing some performance issues, especially in profiles where just font code seems to be pretty hot in random profiles. So I had this idea for a way that we could test it, which is that we would just get like a huge text file and put that into the browser and then just, I guess, scroll up and down or resize the window or whatever, just really terrorize the font code. And it's something that I've done in both Qt and in WebKit in the past, and it's typically a pretty good way to just to stress test a font system. So I figured we could get some classic book like Frankenstein, for example. Usually you can get these type of classics in TXT format pretty easily. Okay, that should be pretty good. All right. And then we should be able to just load any text file into the browser and it will just display it as text. And it does, as you can see. So far so good. And as you can see here, it's pretty laggy, right? It's definitely not smooth scrolling. So this is probably going to be a big and complicated task that will take a lot of work to improve, but with anything performance related, as you should know by now if you've been watching this channel, step one is to profile and measure. Like, until you measure, you have no idea what's going on. So we're just going to grab a full system profile and then, just scroll up and down like this. Capture samples and see sort of what's going on. Okay. And then we will copy the system profile to a file here, just in case something happens. Okay. So right away we can see that web content is 75% of the profile, Windows Server 20%, browser a measly 3.5. But yeah, that's pretty much what I expected. So we'll zero in on web content here and switch to top functions view. So click and open that up so we can see sort of where the time is being spent. And yeah, we can see here, graphics, painter, draw, text run, 93.8%. So totally dominated by text drawing. And then here we see OpenType, CMap, Glyph ID for code point. So this is a function that I've been seeing in random profiles a lot and seems very hot. And in fact, here it's 52.4% of runtime while we are just scrolling up and down is in this one function. So I'm hoping that we can do something nifty about this. So essentially we are drawing text, which here, draw glyph. And actually we're asking the font if it contains the glyph, which calls Glyph ID for code point. And then we are also drawing it, which calls Glyph ID for code point. Okay. We're also checking the glyph left bearing. Let me guess, calls Glyph ID for code point. Okay, yeah, so seems like we have a lot of code that's sort of fetching the Glyph ID for a given code point. But that itself is pretty heavy. So we need to be smarter about caching the Glyph ID for the code point once we've figured it out. And I think there are a couple of approaches to this. I remember one thing that we did in WebKit was that we would cache this information. So every font would have sort of these tables of Glyph ID code point mappings, and I think they were cached in like pages of like 256 or 512 glyphs per page. The idea being that if you were to create mappings for like the entire Unicode range, that would use up quite a lot of memory. And in practice, like you only end up using a tiny number of glyphs of any given font, right? Like if you are looking at Swedish content, for example, online, almost everything is going to be in the Latin 1 part of Unicode, which is like, I guess, the first 256 bytes, actually, or 256 code points. And if you're looking at another language, you might have a different set of code points that get used, but you're never going to need the entire Unicode range. Unless you are looking at like a font demo page or something like that, that specifically shows all the code points. And anyways, that sort of solution seems pretty reasonable here too. And it's something I've been meaning to do for a while. But there's, of course, also other options like just making this code smarter. It seems like it's just calling that API multiple times, Glyph ID for code point. So either we can make that API fast by having it cache internally, or we can call it less. It seems easier to me in this case to cache because in order to map from a Glyph ID to a code point, from a code point to a Glyph ID, you have to look through quite a bit of the tables in the font. So making that fast is probably a better idea. Like all of this gunk here is font parsing, essentially. We're like parsing the font repeatedly to figure out which glyph to use. It's just a tremendously repetitive, redundant work happening here. Okay, so I'm going to try for the, I guess, caching approach first, and then we'll work out what to do if that's not enough. But let's see. Who's calling this? What was it called again? Glyph ID for code point, right? So we're looking at scaled font. Or no, draw glyph or emoji, scaled font, glyph, calls Glyph ID for code point. Glyph, calls glyph, Glyph ID for code point. Calls mfont, Glyph ID for code point, and mfont is a vector font. Okay, so vector font, Glyph ID for code point, which then ends up calling OpenType, CMap, Glyph ID for code point. And I guess that's the call that we see here. Okay. So what if we just put a cache here? So instead of doing that, we will, let's see. First, we just move it out of line, just so we can see it. And then what would our cache look like? So let's imagine that we do the same kind of approach that WebKit does, where we just divide the Unicode range into pages, and then we have sort of a hash map of page index to glyph page. So I don't know if they still do this, but this is something that we did in WebKit. It must have been more than 10 years ago. But it's still, I think it's still a pretty reasonable approach. So doing it system-wide here actually means that all applications get access to it, not just our browser, which will be very nice. So it would be, I mean, the most straightforward approach here would be like Glyph IDs and then page size, or glyphs per page, let's say. Glyphs per page, and let's do 256. It's tempting to do 128 because then you would get all of ASCII. I guess that would make sense, but 256 feels like a nicer number because then you get all of Latin 1, which a lot of web content is Latin 1. So you can get all of Latin 1 in a single page. That's pretty good. Okay. So what are we going to do with this? Well, we're going to have a hash map of page index to, I guess, a non-null operator glyph page. Make that mutable. Okay. And then let's have an API to get the glyph page. Yeah. Okay, and then this API, Glyph ID for code point, what it should really do is something like code point divided by glyph page, glyphs per page, dot glyph IDs, code point modulo, glyph page, glyphs per page. And then the glyph ID will just be cached there and computed once. Okay. So then we just need to figure out what to do to actually populate that thing. Okay. So page index. So the glyph page, glyph pages, we will look for it. So page index. Okay, so if we have it, am I not doing this right? Undefined template, non-null operator. Oh, shoot. Need to include some stuff here. All right. So if we, well, I'm just thinking, like, what's the nice way to do this? Here, we should just return it. Yeah, right. Otherwise, we need to create the page and populate it, insert it into the map, and return it. Right. So okay. Glyph page, glyphs per page. Okay. And then what is the base? The first code point in the page is page index times glyph page, glyphs per page. All right. And then, I guess glyph page, glyph IDs. I is, yeah, so here we just do the lookup that we would do previously. So we populate this entire page, the glyph IDs in this page here, we populate them with the results of calling this on every code point in that page. All right. Page index, move glyph page. And here we just have to be able to return it. This is always a little clunky. Like if you want to insert something, you want to move something into a hash map and then return the thing, you have to take a pointer to it before you move it, because I can't, like at this point here, glyph page is already moved from, so I can't return glyph page. That's why we have to do the thing with the pointer. It's a pattern that always annoyed me a little bit. But yeah, let's see if that compiles. That would be too easy. I mean, it might compile, but like, is this enough or am I forgetting something? We should see pretty quickly if this totally doesn't work, because the whole system, now that I'm using a vector font for the whole system, it should just fail everything. And we are seeing text, so that's good. No, what was it, Frankenstein? Yeah, I thought it was Dracula. Frankenstein, all right. So this already just anecdotally feels much more responsive. But let's take a look at that to see if we actually profile it, like what happens. So previously we had, what was it, like 55%, something like that, in the code point, glyph ID for code point API. Let's see where we are at now. Time distribution looks similar. Switching to top functions. Okay. So what are we looking at now? Glyph ID for code point, 26.92%. All right. And then all the time in there almost is spent in glyph page. So glyph page is now very, very heavy. 22.59%. Interesting. So I have another optimization in mind for this, because a large amount of text is going to be ASCII, right? So I was thinking we would just have a fast zeroth page, because ASCII is in the zeroth page here. Or as I was saying earlier, like all of Latin 1 is going to be in the zeroth page. So for the zeroth page, we can do something like this. Glyph page 0. And we will put that in a separate thing that doesn't require going through a hash map. And I think we will get rid of a whole bunch of all those lookups. So let's see. Page index is 0. Wait, what do we want to do here? If m glyph page 0, maybe we will like populate it somehow. So glyph page 0. like this. Yeah, and we'll move this to a helper. So okay. Oh, wait. Not speaking quite as much as I normally do today because my voice is not fully recovered from COVID. Trying to avoid slipping into a coughing fit here, but so far we are doing okay. All right. So let's populate the page. Oh, it needs to be needs to be const. Of course. Okay. Let's see how this goes. So the idea now is just that for page index 0, we have a fast path, basically, that just bypasses the hash map and goes directly to Glyph page 0 dedicated member pointer. Okay. So okay. It's definitely moving faster than originally, but like faster than last time. We'll have to profile. It does feel like it's almost following the cursor. Not quite. Like I am leading it by a little bit, but this is interesting. Okay, let's see here. Okay. Font, glyph, blah, blah, blah. Okay. Draw glyph. Rasterize glyph is now here. That's positive. So glyph page all the way down here, 3.7%. Glyph ID for code point, 8%. So it's still fairly heavy. And it would probably be valuable to actually try to call it less also, just because if we can resolve the glyph ID once or as few times as possible, that would be better. Then we don't have to hit the hash map as much. So it would be good to do that. But I think this cache is still like a huge improvement very quickly on what we already had. And glyph metrics. Yeah, so now we've only cached the glyph ID lookups. We didn't cache anything relating to metrics lookup, which is going to be like another big part here. So we see fetching the left bearing and the width, which is going to be like the advance for a glyph. And I think we could probably cache the metrics in this glyph page thing as well. But I'm going to leave that for a future improvement. But yeah, I'm pretty positive about this approach here because it seems like we've definitely made it a lot snappier than it was when we started. So I think we're going to turn this into a commit. Actually, let me make a comment here. Glyph fast fast cache for Glyph page 0, code points 0 through 255. Hash lookups for all of ASCII and Latin 1. Let's see. Per code point, Glyph page, caches information per caches information per code point. Stores information, Glyph information, or let's say information per code point. It's segmented into glyphs per page. This cache, yeah. Something like that. We can definitely add more stuff here, like yeah, like the horizontal advance is probably something that would go in here. That we wouldn't have to look that up either. It would be useful. Anyway, let's see. Make Glyph ID lookup faster with a cache. This patch adds a Glyph page cache, which stores segmented stores information about Glyph ID, or stores Glyph IDs, which stores the mapping between code points, Glyph IDs in a segmented page table of pages. This makes font code point mechanically faster by not reparsing the font tables every time you call it. Sure, we can add more information to Glyph page, such as horizontal metrics per glyph. To further reduce time spent in text layout and painting. Yes. Right. So pretty cool. Oh wow, look, you can yeah, this is definitely not performing well. If we can get this if we can get this to go fast, that would be awesome. But that's gonna take more work for sure. It'd be interesting to just profile this selection thing to see what that is. I mean, is it really going to be just more of the same, I guess? Still interesting. Web content. Oops. Yeah, just more text drawing. Rasterizing the glyphs, right? Yeah, glyph metrics here, 17.89%. Yep. We can probably make the rasterizer faster as well, but it's not the largest problem at the moment, so let's wait until it is. Anyways, my voice is about to give up, so I'm gonna wrap it up here, but I think this was a nice, quick little cache optimization that we added here, which makes this a whole lot faster. And of course, the whole system benefits because everything in the system uses the same font code. So it's very good. Okay, if you made it here, thanks for watching the video. It is good to be back. I did not enjoy being sick, so I'm definitely looking forward to making more videos as my voice gets back to normal. Yeah, thanks for checking out the video and hope you saw something cool. I'll see you all next time. Bye.